So I appreciate everybody coming out today after probably a good night last night. A lot of good parties I hear. My name is Amit Heineman. I'm with Rockwell Automation. I've been with Rockwell for 28 years, focused on industrial control systems, and really the last kind of 5 narrowly focused on helping our customers secure those systems. So today we're going to talk about a discussion that we actually introduced last year as part of our RSA session that we did in combination with one of my colleagues around securing industrial control systems. If you want to see that one, it's called U2 Can Secure OT, where we talk about defense in-depth controls. And I decided this year to really kind of dig in a little bit on patch management and some of the challenges we see in that industry and space. So we talk about, this is the disclaimer, everybody's seen this by now. I really like this quote. This is from a group of standards, holistic group of standards focused on industrial control systems. If anybody hasn't, we're going to get into this a little bit more detail, but it's around, this is one specifically around patch management. Now, this is a technical requirement, hasn't quite yet made it out of that state, but it should soon be out into a full-fledged standard, but really kind of summarizes exactly what we have to look at. We have to look at the impacts, we got to look at the risks, compare, whether, and ideally put that in terms of a financial term to present to management whether it makes sense to address that, especially with really critical systems in our facilities. So I had a lot of fun in this presentation coming up with a story, and for those of you that have attended, you've probably seen kind of a trend this year with people telling a little more stories, and so I got one of my brilliant colleagues here gave me this idea around a leaky pipe. So we're going to use that analogy as we go through today, and I'll kind of break that out. But in this scenario, and if you're interested in some of the prompts I use to generate the graphics, take a look at the screen notes when you get them. This primarily used ChatGPT 4.0. So some of the prompts I used here where we look at the increasing tensions that we have in that globally. You look at manufacturing equates for about 11% of GDP, or about 2.9 trillion, I think is the number. And then we look at the age of those facilities. Majority of the facilities are around 25 years old, and those facilities have control systems that are 10 to 25 years old or older. In fact, earlier this week, I was working on a system with a customer that's using one of our PLC5s. And for those of you not familiar with PLC5s, it's one of our mainstay controllers that's 35, 40 years old, and it's still running a critical facility in processing. Good news is they're looking to upgrade that, but you think 35 years ago we had any concept that someone was going to try to insert a malformed packet into that controller? That certainly was not the case. So how do we address this problem? One of the other things here is that one of the other prompts was, a recent study by Dragos in 2023 saw a 50% increase in ransomware targeted at manufacturing. So it's no question, or surprise to see why that is true. One of the previous talks, talked about insecure networks, lack of segmentation in the OT space. We see that lack of endpoint protection. Many of those systems have never been patched since they were put in, and they're running in a 24/7, 365 operation. We don't have a lot of downtime associated. If there is some downtime, it's scheduled. That's sometimes in terms of an 8-hour time period or less. Interdependencies is not very well documented, and that's one of the other risks when we look at starting to patch and understand what those vulnerabilities are. Is the interoperability between those systems, what systems are communicated from controller to controller, for example. It is very simple to create a message instruction from one controller to the next. Some of the newer modern techniques are using OPC UA connectivity. So now we can go directly from a Siemens controller to a Rockwell controller, for example. That's the challenge both with, and then MFA is pretty much non-existent. Although modern control systems now have the ability to do single sign-on or role-based access control and trigger and tie that to MFA if I want to be able to go online and make some changes and or just do some authentication from operator screens. So how do we address this problem? So this is my the character that, in this case, I told ChatGPT to generate me a young engineer, and this is the engineer. So we'll be following this engineer throughout today as we go through this kind of patching problem. Here's the outline. So we're going to talk through about the need for making sure we have some type of automated tools to generate that visibility, then correlate that visibility of those assets into and that inventory into to look at the vulnerabilities associated with that, and talk about a couple different methods for prioritizing those vulnerabilities. Look at some ancillary connections between those. We'll go into the stakeholder-specific vulnerability categorization process from CISA, why a change management team, we'll get into testing, and then ultimately the documentation and change management phase. So obviously this is one of the things that was missing from that list, and I was struggling within a 45-minute to 50-minute talk to cover everything, and is that risk management process and going through and actually classifying the overall risk. We'll get into the 62443 series briefly, but that's one of the areas where I could spend a whole presentation just on going through a formal kind of risk assessment process and going through the classification of those assets down to a different security level. Okay, so going back to our story, our young engineer was hired on at this paper mill. For those of you who don't know that, paper mill to make a ton of paper requires about 25,000 gallons of water. So you imagine as aging facilities, there's going to be leaks in that facility. So one of the things our young engineer was tasked with was understanding the compliance requirements for that specific industry. He had to understand that the PPE, maybe policies and procedures, working on that equipment, whether he had to have a union representative, at the specific area. So much like this same scenario, we have to go through and make sure that we look at what our organizations have, if they have any, procedures and policies today. We need to look at specifically around compliance requirements for that industry. So I just pulled out a couple that in the industrial space where we see patch management really talked about and regulated. So NERC CIP for power generation and electrical distribution is talks about every 35 days for security evaluation. TSA responsible for the gas pipeline transmission, which is one of the critical infrastructure or agencies responsible for kind of enforcement in that critical infrastructure. Talks about categorization and having a process and methodology in place. And look at the last one that I kind of highlighted, this known exploited vulnerabilities. And we're going to come back to that as something they have to validate against. Now, I'm going to contend that there's no way you can do that and stay on top of everything if we're doing that manually. You got to help and develop an automatable process so that we can reduce human error and we can increase the consistency that we have in our facilities. This is a great document. If you haven't seen this, it's from the National Institute of Standards and Technology, and this one's specifically around securing industrial control systems. So it's a guide to secure industrial control systems. And I pulled out the patch management, some of the sections here. So we see, documentation, industry-specific patch procedures, leveraging those OT experts. And I'm going to come back to this because you really have to, most manufacturing facilities have a variety of different systems. As you can imagine, over 25 years, employees have changed, technology has changed, and preferences, and so you're typically going to have a mix of vendors in there. So you have to work with, if you're looking at the vulnerability, and we've identified that we've got to make sure that we involve the manufacturers because they know those systems, they know the vulnerabilities, they can make recommendations, they know the interdependencies of those systems very well. So encourage you to engage them in that decision process as well. Patching in IDMZs, we heard that in the previous talk if you were in here about segmentation, and I talked about that last year. That is critical and as far as the defense in-depth controls to prevent some of the infections we're seeing today. System availability, that's one of the differentiators between OT and IT is that prioritization, right? We see in IT, you've heard of the CIA versus AIC, right? Availability, integrity, confidentiality. In manufacturing, we got to make sure that system is up and running, right? We want to keep those systems up and running. Integrity is probably the next one. and confidentiality rarely used, although we can do that. Modern control systems have the ability to turn on integrity and confidentiality even at the I/O level. Now, that doesn't make sense in a lot of cases, maybe just integrity to make sure that data hasn't been altered, but nevertheless, availability is the key thing that we need to typically focus in on. Take a backup plan and compensating controls. In some cases, you can't patch that system. I talked about the PLC-5. The Rockwell doesn't make those anymore. You have a hard time finding anybody that knows how to program those. And so we might need to put some compensating control. There's no security that's built into that product. So we maybe put a next generation firewall in front of that, to protect that asset. Because that is a vulnerability regardless if it's classified in the CV, whether it has a CVE, right? Common vulnerability and exposure associated with that. 62443, this is part of a series of standards around industrial control system security. If you don't have a patch management process in today, don't start from scratch. Look at, buy this, you do have to buy this. I don't know, it's like $200 for the, individually, and tailor that to your individual, application and for what you want to use within that. Because there's going to be some things that might not be applicable to you. But look at some of the tops there, right? We see the top one as inventory, document, regulated check, supplier validation. You see some consistent themes between the guidance we saw with 800-82 and a standard. In fact, the guidance actually references some of these standards. Patch management routine, looking at implementing patches and use of controls for identified vulnerabilities. So going back to our story, our young engineer has gone through the facility. He followed the policies and procedures, and he's identified an area of the facility that has a leaky pipe or around, specifically around this valve that's an issue. So there's a compromised pipe in the valve that needs to be replaced. So he goes into the store inventory to see what they have in stock to say, okay, what am I going to do to replace this? Obviously, this is a very poor example of any type of managed inventory. There was no documentation there. And so he's got to spend some time to kind of go through and manually figure out what's there and make sure that they've got the part to replace that system. All right, so much like this scenario, we need to go through and leverage, I would say, an automated tool to be able to do this. And there's a variety of them out there. I would say use an OT-specific tool that has the capability of understanding what those different manufacturers are. In this case, I have, Rockwell and Siemens, but there's many, many more out there and a lot of different industrial protocols. So you have to have something that understands and can differentiate between those different systems and get down to the firmware and rev level of that module, right? If I'm trying to use a traditional IT-based tool, I'm going to get a lot of false positives if I can't differentiate between a Series A and a Series B of a module and a firmware version, 1.2 versus 1.6. Because there's vulnerabilities, depending on the system, that are going to affect one series but not another, right? So that's part of the first step in that. And there's OT-IDS solutions out there. Rockwell acquired a company to do this. That's not an OT-IDS. There's other safe active scans in that OT space. And we'll get into that safe active scan because that kind of scares a little bit, people sometimes. So this is the other consideration you need to do when you're selecting that tool is understand the depth and visibility of those networks. This happens to be a Rockwell controller here, but the same is true for other controllers where there's sub-networks. And if we take a look at this backplane, this is a traditional PLC. We've got a controller, a COM module, and a separate network going out to some non-TCP IP-based networks out there. So this is one that's predominantly used by a lot of different vendors called DeviceNet. It has control and power on the same thing. It's used on the same bus, and it's used in a lot of motor control centers will have our DeviceNet MCCs. If I don't have a way to see those devices out there, when I'm going to be missing a lot of my inventory, and again, I might be not exposed to what maybe I've got some vulnerability here I'm not aware of. Anyway, it goes back to that need to make sure that I have something that's effective. So how do we do that? A lot of times we can see if I'm monitoring this with a patch management or an OT-IDS, I'm spanning that traffic, I'm going to miss all this other traffic here. So I either have to have an active way to be able to bridge through that chassis through the backplane, non-TCP IP based, and out those subnetworks. Another method is to use the native engineering tools from that manufacturer to then, as I'm spanning and monitoring that traffic at that switch, I just go out and paint those devices so I can get that information and adjust that at that switch level. So there's a variety of different ways we can get access to that, but just be aware that throughout the manufacturing facilities, you're going to have a bunch of these subnetworks out there. Okay, so now our young engineer has gone through, he's kind of doing his due diligence and just taking another walk through the facility, and he sees another potential issue, another pipe that needs to be addressed. So now he's got to go through and kind of build up a use case. Okay, what's going to have the best or the most impact to my system? So much like this scenario, we need to correlate this to a database. And again, this goes back to an online, I continue, there's no way you're going to be able to keep track of all the different updates. If anybody subscribes to the CISA updates, those come out, sometimes bi-weekly or daily. I've seen them come out with vulnerabilities specifically to the industrial control system. If you don't have an automated way, then you don't have a way to quickly get access and understand what the vulnerabilities are. So one method for doing this, and a common method, is using this common vulnerability and scoring system to go through and do that analysis. So here's just an example of one tool, and majority of them have this capability of filtering those assets, automatically classifying them, correlating them based upon the CVSS, the Common Vulnerability Scoring System. In this case, 3.0 or 3.1. We're going to talk about differences between 3.1 and the newest 4.0 here in a second. But you can build in some logic to say, help me prioritize and figure out what I need to work on, right? The challenge with this, if I just based upon this score, which we'll get into in a second, I'm going to be over-prescribing maybe some areas that I need to be patched and under-prescribing other areas. So useful tool to dig in. So now we need to get into this tailoring. So going back to our story, so now our young engineer, again, is looking back and saying, okay, I've got these systems. I need to look at my is there a way to bypass the water supply while I'm working on this? What's the best way to minimize my impact? What other ancillary systems are going to be affected by that? If I bypass, is that pipe really, can it handle the additional water that's going to be fed through that, through the combination there? And so he's looking outside the facility to look at some of that stuff. So this is that prioritization. So the first step, I see this being left out where people don't go through and tailor this. And this is, looking at the environmental code maturity and adjusting these based upon my specific environmental variables. So if we take a look at this, here's an example. And I tried to make this, as you get the presentations, you'll be able to see this a little more clearly, but you can see there's a base vector, and you get this from the manufacturer, from CISA. So when Rockwell reports vulnerabilities, we provide both a 3.1 score and a 4.0, and we encourage customers to use a stakeholder-specific vulnerability classification as well, which we're going to get into. But as I adjust this score, notice we're going from a 7.1 down to a 2.5. Now, I purposely did this to make sure I showed you kind of the extreme, but it builds out this vector based upon my input. So how do we do this? Well, there's a tool that I've used before. It's called, and I've got the link there. We can just take that base vector that we get from that vulnerability, paste it into the end of the URL, and now we can start tailoring this to our specific application. So when I do that, I'll get this base section here. And then I can start tailoring it, and we're not going to go through each one of those sections. You can do that at your own time. As you hover over that, it'll tell you what it is, kind of the definition around that. But again, here's another example going from 8.1 down to 5.3. Okay, so about 3 months ago, the CISA started reporting this new 4.0. I don't know if anybody's seen this or dug into this, but you're going to see this more and more manufacturers. This will become the norm and the standard going forward. Right now, like I said, on our side for Rockwell, we're reporting both in case customers are already adopting this. So this adds some additional context, around urgency and resiliency to make it more accurate. So there's a base score, much like we saw 3.0, there's a base, or 3.1, there's a base score. Then we see a supplemental. This is sometimes provided typically by the supplier and manufacturer that doesn't affect the base bore. And then there's two different environmental sections and then a threat matrix section. Now the unique differentiator here is that unlike the 3.0, it added that as I was going through and tailoring it was appending to the end of the vector. Here we're actually inserting it in the center between each one. So I tried to kind of make that evident here, again, by the colors, so you get down to threat matrix and it's inserting here. Once again, we're going from 5.9 to 4.0. So if I had my threshold, and I see this sometimes where customers say, hey, we're gonna patch anything above 8.0. Well, if I'm gonna probably be patching things that really don't need to be patched. I need to take a look at some of that stuff, and this is one methodology to go through and help with that prioritization process. Like we saw with the 3.1, we can also use the online calculator, take that vector, although I'm not showing that in this slide, paste it right on the end, and then start my tailoring process for that. I haven't seen that rolled into an automated tool yet, but I suspect, there's other risk factors that depending on the tool that you can use. But as far as, if then else, if I put it in an ACL and if I segment this network, how does that impact this vulnerability? And I have seen some of those, but I haven't seen anybody automate that process into their tool yet. Okay, so now we're going to go through this engineer, going back, he's gone through and prioritized the vulnerability. He still thinks that first valve and pipe the leaky pipe and valve that he found was the right one to go after, but he wants to look at ancillary systems connected, longevity of the asset, again, integrity of those systems. Do they have the capability to handle that additional water flow? So much like this scenario, we need to look at other aspects. I talked about longevity assets, right? Some of those, and that should be a priority, even if it doesn't have a CVE associated with it. If I have some PLC5s or SLICs or some older Siemens controllers out there, and they're no longer being manufactured, that should be a priority. That's a risk, especially if I don't have any on my shelf, and I don't have anybody that understands how to program those to my system. And it aligns with, when we talk about the crown jewels, some type of critical process that's going to affect the entire facility. Some of that's just kind of natural that should be focused on, especially if there are CVEs associated with it. There's another one, you can talk about active exploitation, depending on that regulatory industry that we saw, like we saw with TSA for the gas transmission, they have to go through and prioritize that against the exploited vulnerabilities list. So here's an example of an automated tool where we're looking at that, and so here we can see the common vulnerability scoring system, and once again, all of these provide the ability to click on that and sort and put your own logic. But now we can see, and this tool specifically calls out that is actively being exploited. So it saves me time. I don't have to go out and manually look on some database. And these systems, of course, this is only as good as how frequently that database is being updated. Depending on the OT/IDS vendors, some are manual. A lot of them offer automatic methods for that database to be updated, and usually those are updated, every 2 to 4 weeks. We see those definitions being updated. In this case, we also see some known exploits. So there's toolkits now that are available for this that someone script kiddie could download and maybe go deploy. So again, if all of those start to line up, long asset that's no longer manufactured, we get into has some vulnerabilities, it's actively being exploited, and there's a toolkit, and it's tied to my, it's a crown jewel. Well, yeah, that's gonna go way to the top. Now, there might still be some additional controls that I can put. That doesn't mean necessarily I need to. If the mitigation for that is to flash that processor, that doesn't necessarily mean I need to flash it. I might have some additional controls, or I might already have some of those in place that are protecting that asset, especially if I've done a good job of doing defense in depth controls. Okay, so now our engineer has gone through, he's done his due diligence, he's got his own internal calculation and prioritization, and now he needs to present this to his boss, the engineering manager, and she wants him to go through, she's being very analytical, her own decision tree process to further prove that what he selected was going to be the right choice. I don't know about you, but I really like this office. That'd be a cool engineering office to have. I've never seen that in a paper mill before, but nevertheless, that's what ChatGPT drew up for me. So one tool, this is from CISA. They came out, or they've got this stakeholder-specific vulnerability categorization. And it's really a decision tree that goes through the state of exploitation, the technical impact, the automatability of that, the public well-being, and the mitigation status. And the outcome is this track, star, attend, and act. Now, I can't believe that, this seems just like a strange track star. They seem like they could come up with a better term than track star. But nevertheless, that's what we have. So there's a and hopefully this video plays. There is a calculator here, or a decision tree. So we're going to follow this, maybe. There we go. So here I'm looking at a status and looking at whether it's automatable, either none or active. As you hover over that, you're going to be able to see that status, what the definition is. And I said, no, it's not automatable. What is the technical impact? Is it partial or total? And in this case, I think I said, yes, it's partial or technical. It does have a technical impact. The mission and well-being, and this is a partial or full, and again, it's going to give you the definition. I said partial, and then there's going to be subcategories under that. So the mission prevalence, external support, and I can't read the other one there, but and this is an irreversible step here. So with that information, now I've gone through and it's automatically classified that as a 10, which is the second highest. There's and of course it builds out a full PDF and vector for you. And here's the ultimate step, right? So if we take a look at that track, does not require action. The track star, closer monitoring, you get down to the intent, it's like, that should be done as soon as possible. And the other one is act as the most immediate. One of the OT IDS vendors out there has their own kind of classification process, which I think is kind of unique, and they classify things as now, next, never, right? So they take the CVE and you look at the classification, and again, that's just, I wouldn't take that. That's a great analysis and an excellent team that has gone through that, but you also need to take and tailor that to your specific application. Look at your existing controls again as you go through that. Okay, so now our engineer has gone through, he went through his boss's complex decision tree process, and her process actually reinforced exactly his scenario of, hey, I'm going to patch that primary pipe. It's the one that's have the most significant impact. I can do that in my 8-hour downtime window. But he's got to present this in terms of the people that are going to be affected by that, right? Involve the maintenance person, the supervisor for that area. Obviously, a typical patch management team is not going to be this much, but again, this is a group that ChatGPT came up for me on this one. So much like this scenario, we too need to go through and develop and make sure that we assemble that team. Don't just have one individual. Make sure we get some other inputs to that. We need to tailor that, follow the process we talked about before as far as tailoring, do some critical asset prioritization. And especially on this one, look at alternative mitigation options. And oftentimes from the manufacturer, you'll find, hey, you can flash this. In addition to that, if you can't, here's some suggestions on what you should do, right? So, flashing and updating those systems can't always be done. And especially with the interdependencies. We look at that interdependency between, if you take a typical controller, in its program, it has connections and explicit connections down to different devices, whether it's a drive or an overload or some type of distributed I/O module, and those typically are hard-coded in with a specific version it's looking for. And if I make a change to something in the processing side by flashing that module to the latest firmware version, well, now I've got to go back and not only am I affecting that process, but I've got to change that code and there's can be some escalating decisions that come from that. The other piece here is this patch validation. I had a case where we had a customer that deployed an IIS patch. Good news is their IT department was responsible for their industrial compute platforms, right? So they had their compute platforms, they had them on a scheduled patch management process. The downside is that they failed to check and validate that patch, IIS patch that they were deploying, was compatible with, in this case, some Rockwell software, our distributed HMI. And we knew there was an issue. We had a website that says, here's our patch Tuesday, here's the Microsoft patches that we qualify, but they failed to go through and do that, just that simple test, and it brought the plant down for a day, right? So good news is they learned that process. They know that Rockwell and others have these validated systems there. Now, I'd probably contend that that's better than, even though they lost money, ultimately, holistically, or across that facility, they're in a better place than a lot of other manufacturers because they at least have a process and a procedure in place. And those are the compute platforms are the systems that are under attack. We look at a traditional control system in manufacturing, oftentimes they're flat networks, there's no segmentation, there's no user access control, and all of that can be mitigated. I mean, some of it's going to take time and downtime because we have to re-IP things, and there's software control. There's other things we can do in that space. Leveraging single sign-on, even down all the way to the controller for role-based access control. And that segmentation, IDMZ, are critical pieces that help in that area. And then ultimately, right, this decision, we're going to have a go, no-go decision based upon the input that we provided that team. And the go, no-go is going to be that risk acceptance. And if especially if we can put this in terms of a monetary value for plant management to understand what is the impact if we don't, risk, what's it going to cost us to do this patch, that's what the management team is going to be looking for. And again, there's also the risk acceptance or potentially additional mitigation for that. So now we go to our testing and validation plan. An engineer and maintenance people, person he wants to practice his TIG welding experience and grabs an extra pipe and does all this practice and test, and he's sure they can get this done in that 8-hour time window that they have to fix this system. So much like this scenario, we need to go through and do a formal testing process. Now I know it's hard, especially in a manufacturing facility that's 30 years old. You can have a ton of different systems, no way to have a test scenario, a sandbox that mirrors that exact scenario. Software certainly makes it easier. We have virtualization for testing software. We can quickly roll back that system. We can do software and hardware in the loop. There's a lot of good simulation packages out there to emulate those processes. We've worked with some that actually simulate entire brewery, for example, for operator training. So those can be extended. And there's a variety of different solutions out there to test, and with even physics models, to simulate those different processes, and even controller-to-controller communication. One of the things that should be factored into this, and then so you should test, validate, obviously, make sure we have a backup plan for that. Okay, so now they're ready to go. Going back to our story, they've gone through and they've following their patch deployment process, and they successfully patched this pipe. They get it done within 8 or 6 hours instead of the 8 hours, and do a flow test, and everything is good to go. Okay, so when we do this in the industrial control system side, we need to make sure that we have backups. And this is an area that the previous talked about backing up the backup, and I'll give you an example of a case here in a second. We need to make sure we follow that process and plan, but we also need to make sure that we have backups using I would say an OT-specific change management disaster recovery tool that can differentiate down to program and rung levels of those systems, what changed between version A and version B, and then be able to quickly roll back in the case of I'm rolling out something and it's not going to work. We had a case of a distributed HMI upgrade, and they did their due diligence, tested and validated in their test lab, but they couldn't test everything. There was an issue with interoperability with this third-party system, and they had to roll that back. So it was pretty straightforward on the software side. Quick challenge on the control system side is sometimes you can't roll things back. And so case in point, early Rockwell drives had the ability, didn't have signed firmware, so it had unsigned firmware. We changed everything now is all signed firmware, but if someone took an unsigned firmware drive and flashed it up, you can no longer go back to that unsigned firmware. So make sure you understand those restrictions with those manufacturers, and that should have been part of that test plan again before. And again, we have to prioritize deployment in such a way to minimize that impact. Okay, the final step, documentation. Our young engineer puts his suit jacket back on, goes up and does the documentation, talks about the project, make sure he classifies that, hey, we haven't patched this other system that needs to be patched, and we'll need to prioritize that on the next step. So again, utilize this change management program to be able to differentiate those changes. And I would contend that change management program should also have the ability to go upload a configuration as part of a disaster recovery on a given schedule and insert it in the database and validate that system hasn't been changed. Especially if we don't have a role-based access control integrated in it or any security, which, like I said, in the majority of newer systems now do have the ability to support that. I can be able to tell that someone made a change between version A and version B. Maybe a system integrator went online, made a change to that processor without checking out the program. I need to be able to have a way to differentiate that. So when I do, if there is an issue, I'm downloading the right program, right? And I've got a copy of that latest version. I had a case where a customer did their due diligence, had a change management disaster recovery plan, and also a program, an OT-specific one. The back-end database of that is a SQL database, but they failed to have a procedure to automate that. Now, they had an old version, but it was not an accurate version. So that system was hit with ransomware, and now they had to rebuild a bunch of their PLC code and programs because they didn't have the accurate copy of that system. Now, some of the newer controllers and systems allow for an upload of that and be able to basically reconstitute that program. Some of the older controllers, you're going to lose a bunch of data, run comments, and oftentimes, especially if you don't have the documentation behind that, that engineer is no longer there, it's hard to understand what that programmer did. Okay, so we've talked about a lot today. Obviously, we haven't gone through risk. There's other categorization processes out there. The point is that I'm hoping you guys take away that, hey, we need to start, we can't just rely on the CVSS. We got to start tailoring that. We got to look at other variables around the manufacturer. We got to look at, impacts and make sure you involve your suppliers in that process. I missed the last Q&A. So I'm not sure what happened to my last slide, but the one takeaway is go out. The first thing to do next week, make sure if you don't have an automated tool to go out and help you build out that inventory and correlate that to the latest vulnerabilities, encourage you to go out and do that. The second one in the next 3 months, was develop a change management disaster recovery program, and specifically one for patch management, and make sure that's bought in by your your business leaders. Make sure that's part of your policies and procedures, and that it's you've got training behind it so that it becomes repeatable. And then within a 6-month period, that plan needs to be exercised, right? If you've got a plan but it doesn't get exercised, you really don't have a plan. So with that, I will turn it over to Q&A. If you have any questions, please come up and use the mic here for those. And I'll be available afterwards if someone wants to talk to me as well. All right. I encourage you to go watch on that OT. You too can secure OT. Go back to last year's and watch that one because I talk about a lot more defense in-depth strategies there.